If you look closely at how a raw large language model actually works, you will find a prediction engine rather than a memory bank. These models are completely stateless, meaning they calculate the most mathematically probable next word based on your prompt, and the second that response is generated, the system forgets the conversation ever happened. To get around that amnesia, companies try to feed their own documents directly into the prompt. But routing highly regulated corporate data out to a public cloud provider creates severe compliance liabilities and massive data exfiltration risks. Treecapital Technologies engineered Anven 1.0 to bypass that risk entirely. Instead of renting intelligence on a public server, Anven operates as a sovereign AI, running completely inside a company's own air-gapped infrastructure. This corporate data never leaves the building. Looking at this schematic, divided here down the center, we see how Anven is built for this secure environment. It's a highly efficient 3 billion parameter engine. On the right, its late fusion multimodal architecture processes text and visual data in a unified space. But a secure brain locked in a server room can't do much on its own. To actually execute tasks, that intelligence needs a digital nervous system, connecting it to real-world datasets and external tools. That critical connection happens through orchestration frameworks. These are the structural code layers wrapped around the AI that granted a persistent memory, the ability to trigger external software, and the logic to follow a sequence of steps. You can see this modular concept mapped out here, where heavy cables snap memory blocks and retrieval modules directly into the central Anven model. And when building this infrastructure, engineers generally choose between two dominant architectural frameworks, LangChain and LangGraph. The decision comes down to how much autonomy a task requires. Developers have to decide exactly when to force the model down a strict one-way assembly line and when to let the system loop backward, evaluate its own work, and correct its mistakes. Choosing the wrong framework turns an expensive AI rollout into either a rigid bottleneck or an unpredictable, spiraling liability. LangChain is designed for momentum. Its architecture is a directed acyclic graph, or DAG. Data moves strictly left to right and cannot loop back. It operates through literal chains. The output tensors of one component become the exact input parameters for the next. We can see how this sequential flow works in a corporate legal department. Looking at this RAG pipeline, starting on the far left with a user query, the priority is absolute predictability. A lawyer asks a question about case law. The system instantly converts that text query into a numerical vector embedding and runs a similarity search against a private database. Once it finds matching precedents, LangChain moves to context injection, bundling those documents directly into the prompt alongside the original question. The combined package hits the Anven inference engine. The model reads the strict context, generating a factual answer grounded entirely in the firm's private data. That rigid one-way track makes LangChain incredibly reliable. For clear, multi-step queries where the exact path to the answer is known ahead of time, it delivers fast, repeatable results without fail. When the path isn't clear, LangGraph steps in. It relies on a cyclic graph structure, allowing data to loop backward and repeat pathways. To organize this, LangGraph uses a centralized memory core called the state, which all active agents can read and modify simultaneously. To see exactly why that matters, imagine an autonomous fraud detection agent operating deep inside a highly secure financial institution.
The primary Anven agent evaluates an incoming live transaction and spots something odd, a transfer that doesn't fit standard patterns, but isn't an obvious crime either. A linear system might just freeze or flag it for manual review, but LangGraph allows the agent to pause, realize it lacks context, and autonomously loop backward to pull the last 5 years of the client's transaction history from an internal database. As the primary agent drops those historical findings into the shared state memory, it triggers a specialized secondary agent to step in, analyze the new data, and draft a concise risk profile. By allowing the software to check its own work and ask follow-up questions, LangGraph transforms the LLM from a passive answering machine into a dynamic investigator equipped to handle extreme ambiguity. Choosing between these two tools isn't about finding a universal winner. It is entirely about matching the structural architecture to the cognitive demands of the specific task. Looking at this orchestration blueprint, the heuristic for enterprise engineering is clear. If a process requires straight-line predictability, mandate LangChain. If the task demands deep context retention and autonomous multi-turn iteration, build with LangGraph.
Wrapping these advanced orchestration graphs around Anven's air-gapped infrastructure allows organizations to finally solve the data privacy paradox. They gain elite analytical capabilities without ever exposing their proprietary networks. This separates enterprise deployment from limited public chatbots. We are deploying fully secure reasoning engines locked safely behind the corporate firewall. Pairing a highly specialized sovereign intelligence with the correct orchestration framework elevates the system into an uncompromised, autonomous, and